So and verification is a continuous process. Wherever there is a change that we are making into the design, right, that is where we have to do verification also to make sure that nothing is broken, right. So in the general terms, we can divide this verification to 3 steps. One is logic verification, where it will confirm that okay, functional spec intent is met here. We are not deviating from the functional intent. That is logically it will check okay, everything is fine. Then comes the physical verification, right. Where physical verification means okay, logic is perfect, but now we implemented design. For example, let's say there is a AND gate. There are 2 AND gates driving another AND gate. Okay, this output of first 2 AND gates will be going as inputs to the second AND gate. Okay, now between the 2 wires, the output of gate A and output of gate B, when it goes to gate C, whether is it going in the right distance or is it going the space between these 2 wires is sufficient or is it very close, right? Those are all the things will be checked as part of physical verification. So why do we need to check all this? Because this physical implementation is tied to a process called foundry process, and it will have some rules. If the wire spacing is not followed according to the foundry rules, right, then during manufacturing the 2 wires can get shorted also. We can see some break or short. So these kind of, to make sure that we don't see that kind of problem, right, all this is taken care during the physical implementation and verification. So that is the physical verification, right. And then comes the timing verification, as we just discussed in the previous slide, where the static timing check is what is the verification here. We ensure that okay, this particular design is going to meet the target frequency of the particular, let's say, because the design can contain multiple clocks, and each clock may have different frequencies, right. So let's say from the external world the data is coming into the chip. We have to ensure that the data is properly latched into the design at the right frequency, and internal to the design the data has to be processed, and we have to ensure that the flop to flop timing is properly met according to the frequency. And when we are sending out the data to out of the external to the chip, right, we have to ensure that the receiving chip